Hello and welcome to the Mobile Overview Report webinar for the second quarter of 2019. That's April through June of 2019. Today we have two panelists. We've got myself, Ken Jones, the Vice President of Marketing for Scientia Mobile. And from Norway, we have Jonan Sætherøes. Hello.
Hi, you're getting better and better at the pronunciation of my last name every time.
Excellent.
That's good.
Excellent.
Yeah, so in Norwegian, it's Jon Arne Sætherøes, but you were pretty close. And I am still the Vice President of Products and Innovation in Scientia Mobile. I've been with the mobile business since the last century, I guess you could say.
Excellent. So we have a fair amount to go over this quarter. The Mobile Overview Report, which is now available for download, has 6 sections to it this time. And in this webinar, we're going to talk about graphical processing units, GPUs, and mobile gaming. We're going to look at how Fortnite, a very popular, has started to use GPUs and has all sorts of requirements for it. And we'll also look at the device fragmentation trends. So over the last 4 or 5 years, we've seen a huge increase in the number of devices that are out there. And we'll see some numbers that will support that. The third item is we'll look at Google Lighthouse. It's a web performance and analysis tool, and how to use the image scores in there, and also how to improve them. Next, we'll look at the Wi-Fi technologies that are in smartphones today. Our device detection solution has started to publish and detect information about what sorts of Wi-Fi standards, whether it's 802.11g, N, AC, are in the smartphones and able to be used. We'll have some of the standard mobile overview reports that look at the top smartphones, tablets, and operating systems. And finally, we'll look at a spotlight country. This quarter, we're looking at Sweden. So let's plow forward here. The graphical processing unit. I realize now. There we go. It's moving the wrong page. So graphical processing units have become into vogue since the 1990s, and today they're a standard part of most smartphones. So in 2015, we looked at the number of smartphones that had GPUs, and only 8.25% of them did not have a GPU kind of embedded onto their chipset. By 2019, almost every smartphone that we were detecting had a GPU. In 2019, in terms of looking at the GPU family, so the manufacturer and the family of GPUs that are within that manufacturer, the ARM Mali was the most common GPU family with 39% of all smartphones. And Apple was close behind there with 25% of the GPUs. And looking at the individual GPU models, drilling down from the families, there's been a pretty major change in the types of GPUs that we're seeing in use. Back in 2015, the Qualcomm Adreno 305 had 12.41%, which was the most popular GPU model, followed by the Adreno 330. And then you got into some of the PowerVR GPUs. In 2019, almost all the top 4 are coming from the Apple GPUs. Now, Jonar, maybe you can jump in here. The PowerVR technology is basically integrated into the Apple GPU chip now. Is that correct?
Yeah, so it can be, I'm a little bit confused myself, to be honest, but it can be kind of confusing because yeah, there's we often talk about chipsets on mobile devices, what kind of chipset there is. So, for example, on the Apple A10 chipset, there's some sort of Power VR GPU chip. I don't remember which it is, but with Whirlpool, where this data comes from, it's organized in the way that a given device has a chipset and a GPU family and a GPU chip name. So you get all the information that you need. So there's yeah, the confusing part here is of course that there's especially from Apple, there's some branding and marketing involved here. The Adreno GPUs are also better known as the Snapdragon chipset, and the Mali architecture, which by the way is a Norwegian invention. As far as I can remember, it was some sort of a university in Trondheim, Norway. You know, had a good idea about this a couple of years ago. But this is yeah, this is in the Galaxy devices from Samsung.
Right. Excellent. Okay. Now, how does this play out in the real world as it's being used by applications, especially in gaming applications? So Fortnite, for those of you who have been living under a rock, is a very popular game, especially among the young folks. It's a multiplayer game, and it has, for its mobile component, some requirements or recommended requirements for play, and they've set the bar for Android that you should have a 64-bit device with Android 8.0 or higher. That's actually a pretty we'll get into this a little bit later, but setting the bar at Android 8.0 excludes a fair amount of the market right there. It says 3 gigabit of RAM, and then some recommendations for the GPU at Adreno 3530 or higher, and then some other ones. On the iOS side, it's a little cleaner because you know, there's less to deal with, but they recommend the iOS 12.0 or above in terms of the operating system. And the models, when they list them out here, it's assumed that the chipset you know, is known there, especially the GPU chipset. So drilling into, when you look at the stats, only 19% of Android devices today actually meet this level of standard that Fortnite has set out there. And most of those phones, or at least the most popular phones on the Android side that meet that, are the flagship Galaxy from Samsung. So you've got the S8 with 2.1%, the S7 and the S9. All of these Samsung devices are kind of the most popular ones in use that will meet that sort of requirement. Huawei has some phones in there also that meet that requirement. So that's one way to slice up the data, looking at the operating system. And another way to look at it is the price of the phone. So one of the things that you can pull from our device detection system is the MSRP, the manufacturer's suggested retail price for the smartphone. And what we've done here is say, you know, of the devices that are compatible or meeting the requirements that Fortnite sets out, what is the price point for those? And over 85% of the devices that meet those requirements are priced higher than $800 US. That gives you an idea that you know, this is a pretty premium standard that has been set out there by Fortnite. So it's excluding most of the market that has phones that are priced under that $800 mark. I suspect that as time goes on, GPUs will become more powerful and be included in lower price phones. But of course, there's always this moving escalation of GPU power and pricing that will probably continue to keep the highest end GPUs in the most expensive phones. All right, moving on to device fragmentation. Let's take a look at some trends that we've been seeing from 2015 to 2019. We've been putting out the mobile overview report for almost 5 years now. And one of the things that we can do is we can take a fairly long view of the time frame of smartphone trends. And with mobile, the underlying technology for our mobile overview report is a device detection system called Wordful that our company puts out. And it's the most accurate and complete device detection solution on the market. Back in 2011, there were about 15,000 device profiles that were tracked by this device detection solution. And at the time, we were being told that the world is consolidating. There won't be that many devices that are going to need to be tracked. That prediction turned out to be quite wrong. So in 2019, we're tracking over 63,000 device profiles. Now, granted, not all those devices are being used today, but a good measure of them are. And the pace at which we're adding devices continues to grow at around 20% per year. How many of them are actually being used today? Well, let's look at the statistics by continent. So in Asia, back in 2015, our usage data tracked about 5,700 devices. That number's doubled to over 11,000 devices. So, and that trend is pretty consistent in terms of the doubling across different continents. So we continue to see a pretty strong growth in particularly smartphone fragmentation. Looking at tablets, it's a little bit different picture. First of all, there aren't as many devices. The Apple iPad has dominated this market for many of the last 4 years. And that's one of the reasons why you don't see as many tablets being tracked. The market here seems to have slowed down, in my opinion. And most of the top devices are Apple iPad devices, and they tend to be used longer. The replacement cycle is slower than smartphones. So we haven't seen the same sort of growth. We see about a 10% growth, not as high as the smartphones. But how does this work, and how does it impact a lot of developers or websites in the real world? Well, we were looking at one of the reasons you might want to track fragmentation is to figure out, if you want to ensure that your website renders well or provides a good experience on phones, you might want to test it out on a certain number of phones. How many phones are you going to need? What we've looked at is, if you look at the top 21 smartphones, that will cover about 37% of usage in Asia, 56% in North America. So, it would be great if you could just check your results on a pretty small number of devices, like top 20, and be sure, but that doesn't quite get you there. And the problem is you have a very long tail of usage in terms of in order to get to like a 95% confidence threshold. You go out pretty far on what we call the kind of the long tail here. And we've kind of rank ordered the usage by smartphones in different continents. And the point here is to try to figure out, you know, how many devices do you need to hit this 95% threshold? And on the next slide, we kind of break down where you cross over that line. So in Asia, you need about 534 devices to do it. Now, practically, no one will probably test on 534 devices, but there's different techniques that you can do in order to, you know, get that same level of confidence in terms of operating systems. But this gives you an idea of the level of fragmentation that's occurring out there. The world is becoming more personalized to various people and their devices, and you know, we're not moving toward a simpler environment. It's a more fragmented one. So next, let's look at the Google Lighthouse web performance tool and the image scores that you get in there. And I'll let Jon Arne walk us through some of the analysis we've done about how to improve your scores in Lighthouse, particularly as it pertains to image scores.
Mm. Yeah, so yeah, Lighthouse is one of the tools, performance testing tools that has gained popularity last year or so. We mentioned also webpagetest.org, which is probably one of the oldest, but still one of the most useful tools for testing and analyzing performance out there there is. But yeah, Google obviously has included a metric of performance. You know, how fast and responsive the site is in their index. So if you have a slow site, your search engine rankings will also be worse, and the opposite. So, and this is sort of built around how Lighthouse works. So that's why Lighthouse is gaining part of the reason why Lighthouse is gaining popularity. One of the things the Lighthouse tool is looking at is images, and how optimizing images in certain ways will make the performance of the website better. And this slide we're looking at now, it suggests that this particular site should size the images correctly. In this case, I guess the images have been a little bit too big in terms of pixels, and then use efficient file formats, and so on and so on. So and these milliseconds often, but in this case there's actually more than a second to save. They add up, and of course one can address this manually, but there are, if you switch to the next slide now, Ken, there are 3 or 4 different strategies you can choose in order to address image optimization and making sure that your images are optimized well. The first option here is how the images are when they come out of your favorite tool for editing images. Of course, you can do a lot of optimization and tweaking and tuning from Photoshop, like we have an example of here. But in this experiment, on the next couple of slides, we use this as sort of the baseline. This is how the image is by its own, when no optimization and no tweaking has been done. So you can also think of it as a JPEG coming straight out of your camera or something like this. And then the second strategy might be to use some sort of automated task runner or have some processes optimizing your images while you're building your website. Grunt is one of these task managers or task runners, which can loop through all the images in your web project that you're developing and optimize these images and maybe even convert them to different formats and sizes, so you can put them together with your responsive image tags, for instance. But all this is happening built on when you're actually programming the website. So it doesn't make use of any information available, coming from with the HTTP request and so on. But option 3 does make use of that. So the way that runtime optimization differs from build time optimization is that runtime optimization can take input from the HTTP request for the images and do some limited but still optimization that can't be done offline or build time. The best example might be to analyze the HTTP request and looking for WebP support, and then convert the image to WebP. This can be done in many different ways. Usually, among the companies offering runtime optimization, this is done through some sort of regular expression on the user agent string or other less scalable ways. But also through client hints, which is slowly but steadily evolving into a standard. Client hints enable dynamic resizing of the images, but this has to be done runtime on a server capable of performing these kinds of actions. Fourth option is where it still happens runtime, but you have more and reliable information about the requesting device. You don't have to do dirty tricks like user agent sniffing or regular expressions and things on the HTTP header. You can look up in the device database like WRFL and get all the information you need from there before you optimize the image and return it. So if you switch to the next slide, it's important to understand the difference between runtime optimization and the device-aware optimization. With runtime optimization, you definitely get a lot of information out from the HTTP requests, which you can use to optimize the image. But then again, it requires a lot of maintenance. And this is sort of the core of the WRFL offering and the WRFL API and the WRFL database to let Central Mobile handle the maintenance and make sure the data is up to date and all the logical operations in the API is working and up to date. So that's the whole purpose, that you can actually trust that the WRFL API is doing the device detection correctly. While if you're using regular expressions on certain HTTP headers fields like the user agent string, you have to constantly monitor and maintain this expression in order not to get false positives or even broken images. But still, runtime optimization without device detection, it works. If we compare to the baseline, you can switch to the next slide now again. If we compare to the baseline, which in this case is 100%, the runtime optimization is 60% of the original baseline. So 40% less data if you look at the HTTP information in the request and use whatever you can there to optimize the image, whether it's to resize with the help from client hints or convert to WebP from other HTTP header fields. So it's definitely a good thing. But then it will only get you so far. It's difficult to find the right size of the image. In many cases, the images are on the web today, they're too big. You rarely find an image which is small or smaller than it should be, and this is difficult to detect without proper device detection. With Wurfel, you get the size of the screen, for instance, both in terms of physical pixels with the resolution of the screen, but also the recommended maximum size of the image in CSS pixels, if you will, or display pixels. And thanks to this extra information that device detection brings you in Image Engine, we're able to reduce the traffic, the image payload down to 34.5% of the original, which is huge. And this is roughly half the traffic compared to the runtime optimization as well. And this, of course, affects the load time of the web page. It's going to be a faster page load with all the good things that comes from that, and it's also going to be lower operational costs if you're on a CDN charged by gigabytes transferred and things like this, for instance.
Right. So, just to clarify a couple of things, the Wurfel device detection that we refer to, it's built into Image Engine. So it's although we've kind of highlighted that device awareness, it's important to, seems to automatically go on. It's important to point out that not only do we get that device awareness, but it's seamlessly integrated into the image optimization process, and it also is put out there on the edge servers for a content delivery network, so to make this all seamless.
Yeah, that's great.
Okay. Great. Now, a point of clarification also. So, how does this relate to image or responsive images? So, the kind of the build time optimization might include responsive images, but how does something like Image Engine relate to the responsive images approach?
Yeah, it's a easy question with a long answer, I guess you could say. But with built-time optimization, you have to be a developer. You're developing making the HTML and making all the image tags and defining your breakpoints, and how many different derivatives of the same image, different sizes and versions and formats of things you need from the same image in order to fit your breakpoints, the number of breakpoints you have. So it's going to be the image tag will be long. It will be multiple lines, maybe 10, 15, 20 lines long, and then you also need maybe 5, 10 different images, and this you need to create. Either manually or through a task runner, like we mentioned, and this will, it will definitely work. It will the browser will pick the right image depending on your breakpoint, or at least the closest image. There will rarely be a 100% fit, but at least it's a step in the right direction. But it's going to be also a maintenance issue there, because once a new device or a new screen or something enters the market and you figure out that you need a new image format or a new size of the image, you would need to go back in time sort of to recreate the specific breakpoint of the images. But with Image Engine, you can reduce the number of lines basically that the developer has to create in the image tag down to 1 or 2 lines, and let Image Engine handle the format conversion and even the resizing of the image. So it's yeah, it's basically dividing the work in two. You know, whatever can be automated, Image Engine does, and then the developer can you know, focus on the design of the web page, and then yeah, make sure that the Image Engine can do its job by converting and optimizing the image according to the current situation, the current devices on the market.
Great. So if anybody's interested, you can start a free trial for Image Engine at imageengine.io. Just contact us, and you can see the impact it has on your Lighthouse scores. Next, we'll take a quick look at the Wi-Fi that we're seeing in various smartphones. One of the new things that we've added to the Whirlpool device detection system is the ability to identify the Wi-Fi support on a particular smartphone. So back in 2015, the 802.11n was the most common standard on most smartphones. By 2019, 802.11 AC was the most popular and most advanced version that we saw, with 62%. Most of this was this upgrade was caused by the shift in iPhones. They moved most of their phones from 802.11n to the 802.11 AC during that time frame. In the Android world, there's been some movement, but most of the devices are either on 802.11n with 50%, and only 43% are on the 802.11 AC. Drilling into our spotlight, here we have Sweden. One of these days we'll get to Norway.
Thank you.
Getting close. The devices that we see in Sweden, 49% of them are smartphones, which is a little bit higher than what we see as our benchmark with the USA. And in terms of the top devices, the iPhone 7 is the most popular device in Sweden with 10.82%. And you know, in the US, the iPhone 8 Plus is the most popular device at 8%. Similar across both of them, the iPhone makes up a huge part of the market here. The top 5 phones are all Apple devices, and it's pretty similar to what we find in the US. The first non-iPhone device that we find is the Galaxy S8 with 4.32% of the smartphone usage. And looking at the entire top list, almost all of these are either iPhone, or actually all of them are either iPhone or Samsung devices. On the tablet side, the iPad Air 2 is the most popular tablet. And once again, almost every device that you see here is an Apple iPad. The 2 exceptions being the Samsung Galaxy Tab A 10.1 with 4.5%. And down at the bottom, you've got the S3 9.7. On an operating system level, 55% of the devices that we monitor for smartphones are iOS devices, iPhones. And in terms of the cost of the phones, both the Sweden and the US are what we would call premium markets. Most of their phones, 75% of Sweden's phones, have an MSRP, manufacturer suggested retail price, of over $700. The age of the smartphones is a little bit different from US versus Sweden. Sweden tends to have a little bit older phones. Only 11% of the devices that we're seeing are less than 1 year old. And they tend to hang on to their devices a little bit longer. You can see that, 2 to 3 years, 3 to 4 years, and 4+, they tend to have a little bit higher usage than the USA as a benchmark. Moving on to our standard reports for the mobile overview report, just real quickly, the top devices are the Apple iPhone 7 with 5.41% on a global basis. New to this list is the Galaxy Samsung S9 here with 1.56% of the global smartphone usage. It's still, we talked a little bit about concentration of the markets when we were talking about fragmentation. You can get a sense for in certain markets like Oceania, these top 20 devices that we track account for 66% of or 65% of the market, and only 34% for the remainder of beyond the top 20. And that kind of flips when you go to something like Africa, where there's a huge long tail of devices out there. In terms of operating systems, we've seen some changes over the last quarter. The 12.3 version of iOS is now the most popular operating system on the Apple side. It came out in early May of 2019, and by the end of the quarter of Q2, it had 71% of the market, this blue part. So Apple continues to have a pretty good track record of upgrading their operating systems successfully, as opposed to Android, which continues to have some issues in terms of lagging or a huge install base that is on something that is older than the most current versions. In fact, 25% of the devices that we are now calling legacy, anything less than 6, we consider that a legacy device or operating system. That's 25% of the market. Interestingly, though, 9.0 is now the most popular operating system outside of that. And by the end of the quarter, they were at 27%. So things are getting slightly better. I think this picture is better than it has been in the past, but still, it's not nearly as effective as this picture for iOS. And that's it for our mobile overview report. If you're interested in getting more information from us, and maybe a customized report, we have a lot of services that we can offer you in terms of geography, drilling down into certain continents or countries, or even smaller geographic areas. Device capabilities, we have over 500 device capabilities. Some of them we've touched on today, like Wi-Fi support, GPU chipset, display resolution, audio and video codecs, economics. We can look at the price and or age of a device that's in use. And we have a long track record now of many years that we can do analysis over a certain time frame. So contact us. We're more than willing to work with you to define what sort of data requirements you have and provide customized data reports. And also, if you're interested in the Warful device detection solution for your own purposes, whether it's advertising or analytics, contact us and we can help you trial that solution. And that's it for this report. Jan Arndt, thank you for joining us today.
Thank you for having me.
Okay. We will see everybody in 3 months. Thanks. Bye-bye.
See you.